In the last lecture, we have learned how to take a measurement and report the data correctly. We always report all the certain digits and one estimate. With any given measuring tool, we will report all the numbers we can read from the marks on the tool and one estimate digit. All right, we're all experts now in taking a measurement. However, in reality, it doesn't happen very often that your job is simply to take a measurement. Very likely, you're going to do some calculations on your measured data. For example, some measurement is taken, you did some calculation on your data. Now you get 5.83498 on your calculator. Now you're facing another job. How do I report my data? Do I report all the numbers on my calculator, or do I report 5.8, 5.83? So what will be the format of the data I report after I do some calculations on a measurement? Today, we're going to learn a set of rules that you will use to help you to decide to which digit you will keep your calculated result from measurement. But before that, let's assume you know to which digit you're going to keep. For example, let's assume we have learned the rules. We did the calculation now. We see 5.83498 on my calculator. Let's assume by following the rule, we know we'll keep certain digits of the number. But how do I do that? First, assume, let's say 5.83498. Let's assume I'm going to keep two sig figs. I'm going to keep only two sig fig. I need two digits of sig fig. How can I do that? Well, given a number, we have to round this number off to two significant figures. So what do we need to learn before we learn the operational rules, calculation rules for measurement? We need to learn rounding off numbers. We need to learn the process of deleting unwanted or non-significant digits from calculated numbers. Well, the rule for this one, deleting unwanted digits from calculated numbers, are pretty straightforward. If the first digit to be deleted is 4 or less, you drop it. If the first digit to be deleted is 5 or greater, you drop the number but increase the last return digit by 1. Okay, for example, again, we're going to use this number 5.83498 as example. Make sure we're clear what this number is. The number we see on the screen right now, 5.83498, is a calculated answer from measurement. Let's assume, okay, we need to, by following the rule, we haven't learned the rule yet. We're going to learn the rule right after this. But assume we know by following the rule, we will keep 3 sig figs. How do I do that? 3 sig figs, 1, 2, 3. The next digit is 4. 4 or less, you drop them. So 3 sig figs, the answer will be 5.83. Okay, let's assume I got this number 5.83498, and by following my calculation rule that we're going to learn later on, I need to keep 4 sig figs. How do I do that? Well, 5.83498 to keep 4 sig figs it will become 5.835 because that's 4 sig figs. The next digit is 5 or above. You drop them, you increase the last return digit by 1. Right now it's 4, it becomes 5. Okay, that's the rounding off process. Some practice. Round off the following numbers. Assume all the numbers are calculations from measurements. Round them off to 4 sig figs. 1, 2, 3, 4. The next digit is 4 or less. Drop them. So the answer will be 58.66 in this case. Next one. 4 sig figs. 4 sig figs. The next number is 5 or above. You raise it up. Okay, so it becomes 1300. Wait a minute. Now you need to be very careful. When the numbers end with 0, you need to be very careful. All right, to have 4 sig figs, if you report your number as 1300 as it is, this number has only 2 sig figs. Be careful. If you're following the rounding off rule and you get a number, you need to make sure all the digits in your number, they need to be significant, which means you need to find a way to make the trailing zeros, 2 of them, you need to make them significant. Therefore, to report this rounding off answer correctly, it needs to be 1300 with a decimal. By doing that, all 4 numbers trailing zeros with a decimal are significant. Okay, some of you may argue, wait a minute, they're the same thing. Why do you have to force us to add a decimal there? Well, they are not the same thing. 1300 point means the answer is closer to 1300 other than 1301 or 1299. That's what this number means. The meaning of this number is the answer is closer to 1300 other than 1400 or 1200. The error for this one comes by 100. The error for this one comes by 1. Okay, so this second example gives us a unique situation you need to pay attention to. The next one, 4 sig figs. 4 sig figs. 4 or less, you drop them. All right, 5866. Wow, if you do that, you made a big mistake. The original number is in the level of 5 million something, is 5.8 blah blah million. It cannot become 5,866. For numbers like this, after you do rounding off, okay, you have to make sure the magnitude of number cannot be changed, only the number of sig figs, which means this number, after rounding off to 4 sig figs, will become 5866,000. All the numbers dropped need to be replaced with zeros. The digits need still to be there. Now let's look at the operational rules on measured data. The rules that help you to decide how many digits you're going to keep once you do some calculations on measurement data. There are 2 rules. Rule number 1 applies to multiplication division. It tells you the number of sig figs in your answer should be the same as the number in the original measurement. that has the fewest number of sig figs. An example, there are two measurements. You're doing a multiplication on these two measurements. The first number has 4 sig figs. The second number has 2 sig figs. The rule tells us, regardless of what you're going to see on your calculator, your answer should have only 2 sig figs. This is what you're going to see on your calculator once you punch in those multiplication numbers. Now what you need to do, you need to round this number off to 2 sig figs. Luckily, we learned how to do that on the last slide. So 7.381 to 2 sig figs. 8 is 5 or above. You raise the number 3 to 4, so 7.4. Practice. Complete the following calculation on measurements. Okay. 3 sig figs, 2 sig figs. You know your answer can only have 2 sig figs. You punch this number into your calculator, this number into calculator, do a multiplication. What you're going to see on your calculator, you're going to see 6.33. Now you need to round 6.33 to 2 sig figs. 4 or less, drop it. So 6.3 is the answer for the first one. The second one, 6.50, 3 sig figs, 2.00, 3 sig figs. Your answer should have 3 sig figs. You punch these numbers into your calculator. This is what you're going to see on your calculator. Now, make sure you will not report 13 as your answer. You're going to make 13 into a number that has 3 sig figs. What do? You add a 0.0. The number should be 13.0, 3 sig figs. Next one, or this is almost the same as the second one, 6.50, 3 sig figs, 2.0, 2 sig figs. The only difference between this one and the last one is that the second number has only 2 sig figs. Well, the first number 3 sig figs, the second number 2 sig figs, your answer should only have 2 sig figs. You punch these numbers into your calculator, you get 13. 13 has 2 sig figs, that's the number you're going to report. Okay, hopefully these two practices help you to understand a little more about these rules. Rule number 2 applies to addition subtraction. In this case, you do not look at how many digits of sig figs you have in their measurement data. You look at how many digits each of them has after the decimal. And your answer should have the same number of digits after decimal with the measurement that has the fewest digit after decimal. Two measurements. The first one has 3 digits after decimal. The second one has 2 digits after decimal. By the rule, your answer will have 2 digits after decimal. Keep that in mind. Now, once you understand that, you punch these numbers into your calculator. This is what you're going to see on your calculator. As we just discussed, you will round this number off to a number that has 2 digits after decimal. 2 digits after decimal. This is 5, so you raise the number ahead up by 1. It becomes 31.28. Practice. 4.22, 1.5, you punch them into your calculator, you get 5.72. Now you need to look at the rule, make a decision, what you will report. The first number has 2 digits after decimal. The next number has 1 digit after decimal. You can only keep 1 digit after decimal. 1 digit after decimal. 2 less than 5, drop it. 5.7. That's your answer. Next, you punch in 6.50 minus 2.50 on your calculator. You see 4 on your calculator. Well, are you going to report 4? Of course not, because the first number here, it has 2 digits of the decimal. The second number also has 2 digits of decimal. So your answer has to have 2 digits after decimal. Well, how no digits after decimal? Well, add 2 digits. Report it as 4.00. Next, 11.31, 2 digits of decimal. Next, number 1 has no digit of decimal. You know you cannot keep any digit after decimal in your answer. So punch these numbers into your calculator. You see 10.31 on your calculator. Okay, you learn the rule. The rule tells you for addition, subtraction. Make sure in my case, in this case, I cannot keep any digit after decimal. Well, the number becomes 10. Now, again, you need to be very careful. Whenever an answer in your calculation ends with 0, you need to be very careful. Okay, you are following the rule. However, there's one more thing you need to keep in mind. If you are following the rule to get an answer, all the digits in that answer must be significant, which means you need to find a way to make the trailing zero significant. If you report it as 10 only, the trailing zero is not significant. As a result, you will add a decimal to your answer. So you're going to report 10 point. Can I report 10.0? Of course no, because you know you cannot keep any digit after decimal. That's the rule, because number 1 has no digit after decimal. We basically finished the operation rules for measurement. However, let's look at an exception. Okay, exact numbers. Exact numbers have no uncertainty, so they are believed to have an unlimited number of sig figs. Like 1 inch equals 2.54. You can, in this case, 2.54 doesn't have 3 sig figs. It has a limited number of sig figs because it is not a measurement. It is an exact number. Exact numbers never limit the number of significant figures in your answer. Measurement does. Example, you're performing 10.25, which is a measurement, multiply it by 2, which is exact number. So you measure the length of a sample, and you have 2 of those samples. You want to know the total length. So you use the measurement 10.25 multiplied by 2. Number 2 is not a measurement. It's exact. So number 2 doesn't limit your sig figs in your answer. This one does. 10.25 has 4 sig figs. Your answer will have 4 sig figs. You punch in this number multiplied by 2, you see 20.5 on your calculator. Well, you cannot leave the number as it is because this number has 3 sig figs. You must make your answer into 4 sig figs. So the report becomes 20.50. Exponential notation, sometimes you have to use a scientific notation to represent your answer or a measurement. Okay, exponential notation or scientific notation is a number written in this format, where a is a number, is called a coefficient, is a number greater, no less than 1, but less than 10. N is a whole number. And these are the terms related to exponential notation or scientific notation. In a scientific notation, the coefficient decides the number of sig figs. In this case, this scientific notation has 3 significant figures. Rules helping to convert from a decimal to scientific notation. We are not going to go into details how to do this. You need to know this. If you don't, find some online tutorial, do some practice. It may take you 10 minutes, 15 minutes. You will be good. What I do want to remind you is that during those conversions from a number to scientific notation or from a scientific notation to a regular number, the number of significant figures must stay the same before and after the conversion. Example, a data reported at 300 point. Okay, because this number has a decimal, this number has 3 sig figs. So when you convert it into a scientific notation, the coefficient must be 3.00, must have 3 sig figs. A number reported as 300, no decimal. 300 has only 1 sig figs. After converted into a scientific notation, the coefficient needs to be 1 sig fig. 300.0 to scientific notation. 300.0 has 4 sig figs, so the coefficient must be 3.000. I hope these 3 examples helps you to understand something. 0.004890 trillion zeros, because you have a decimal, trillion zeros are significant, so this number has 4 sig fig. Therefore, the coefficient has to be 4.890. It cannot be 4.89. Multiplication and division in scientific notation. When you do multiplication, you add the exponents. So this one becomes 10 to the power of 9. 6 plus 3 equals 9. To do division, you subtract the exponent. This one is 10 to the power of 3 minus 6, which is 10 to the power of -3.